Good morning student. Let's start today's class. Today we are going to study about the method of transistor biasing. Okay. In previous class we have studied we have seen that the need of biasing and and the biasing of transistor or need of biasing of transistor. Okay. Now see the different method of biasing. Okay. Transistor biasing. Okay. Now in the transistor amplifier circuit, this transistor amplifier circuit drawn so far biased was done with a added of VBB. Okay. Now now which was separate from the battery of VCC. Okay, used in the output circuit. However, in the interest of simplicity and economy, it is desirable that transistor circuit should have a single source of supply. The one in the output circuit VCC. The followed are the most commonly used method of obtaining transistor biasing from the one source of supply. That means uh, in previously we have said that there is two source are there for biasing. Two source are there, one is VBB and one is VCC. Okay, but for the simplicity of the removing of one source, only using one source, we use only VCC, and this happened or this is possible in this biasing methods. Okay, there is three types of biasing methods. One is base resistor method, one is biasing with feedback resistor, and one is voltage divider biasing method. Okay, now in all these methods the same basic concept is employed, that is required value of base current, and hence the IC is obtained from VCC is the zero signal condition. Okay, the value of the collector load RC, okay, is the selected keeping in the view 1 minute. The view of sits, that means the let's see the base resistor method. Okay, first method. Okay, let's see what is base resistor method. In this method, a high resistance RC short several hundred of kilo ohm. This high value of R resistance, high resistance, which is RB. Okay, which value is several hundred kilo ohm. Okay, is connected between the base and the positive end of the supply of NPN transistor. The first one is NPN transistor, and this resistor, okay, this RB resistor is connected between the voltage, that is positive voltage, and the base of the transistor. Okay, and here the required zero signal base current is provided by VCC. Okay, this VCC provide required base current, uh, required zero signal base current. Okay, now it flow through the RB. Okay, this RB. Okay, this base current IB is flowing through the RB. Okay, it is because now base is positive with respect to emitter. Okay, that is base emitter junction is forward bias. Base emitter junction is forward bias because base is positive and emitter is negative, that or ground. Okay, so base emitter junction is forward bias. The required value of zero signal base current IB, okay, can be made to flow by selecting the proper value of the base resistor. Okay, this base resistor selected to get the required IB. Okay, now circuit analysis. Let's say this is the base resistor method circuit. Okay, then the circuit analysis, it requires to find the value of RB. Okay, so that required collector current flow in the zero signal condition. Okay, that then let IC is the IC be the required zero signal collector current. Okay, so IC we know IB equal to IC by beta. Okay, then consider the closed circuit uh, flow calculation and apply the Kirchhoff's law, voltage law. Okay, okay. Now here you see in this circuit. Okay, in this circuit we apply Kirchhoff's law. Okay, then we get we apply KVL. Okay, Kirchhoff's voltage law. We get our VCC equal to IB RB. Okay, and plus VBE VBE. Okay, in this, sorry, not in this direction, this direction. Okay, this direction apply Kirchhoff's law. Okay, that means ABN. You see, here you see, consider the closed circuit ABEAN. ABE A sorry, ABENA. ABENA. That closed circuit. This closed circuit. This closed circuit. Okay, so in this closed circuit, consider or apply KVL. Okay, applying KVL, we say we know VCC. This VCC equal to IB IBRB plus VBE. Okay, now here IBRB equal to VCC minus VBE. Okay, RB equal to VCC minus VBE by IB. Okay, as VCC and IB are known and VBE can be seen from the transistor manual or this VBE. Okay, therefore the value of RB can be readily found from this expression. Okay, since VCC and IB is known, okay, are known, and VB is from the manual, transistor manual, this is fixed. Okay, so we can calculate RB. Okay, since VB is generally quite small as compared to the VCC. Okay, the former can be neglected. Okay, this VB can be neglected, so this expression became RB equal to VCC by IB. Okay, because VB is very negligible in accordance with the VCC. Okay, so we can ignore VB. Okay, then it may be noted that VCC is fixed. Okay, known quantity. Okay, and VCC is no fixed known quantity because we apply VCC. Okay, this VCC, let's say 5 volt or 6 volt, we know this VCC. Okay, so VCC is fixed known quantity and IB is chosen as some suitable value. Okay, hence RB can always be found directly, and for this region this method is called fixed bias method. Okay, so this is called fixed method. Since VCC is fixed and IB we can choose suitable value, so here RB always found directly, so this is called fixed biasing method. Okay, now stability factor. Okay, in the stability factor. Okay, this stability factor is the formula of stability factor is beta plus 1. This is the formula. Okay, in the fixed bias method. Okay, the biasing of the biasing, IB is independent of IC. Okay, so that IB del IB by del IC equal to 0. This is the differentiation. Okay, so for differentiation of a constant, okay, is 0. That means the IB, since the biasing IB is independent of IC, or IB is fixed according to the IC. Okay, so the differentiation of both is 0. Okay, now putting this 0, with stability factor is beta plus 1. Okay, then thus the stability factor of the stability factor in a fixed bias is beta plus 1. That means that IC changes beta plus 1 time as much as any change of ICO. Okay, for instance, if I beta is 100, okay, then S equal to stability factor is 101, which means IC increase 101 time faster than the ICO. Due to the large value of S in the fixed bias, it is poor thermal stability. Okay. Now advantages is that the biasing circuit is very simple as only one resistance RB is required. Okay, biasing condition can easily be set and the calculation are simple. Okay, there is no loading of the source by the biasing circuit since no resistor is employed across biasing base emitter junction. Then disadvantage is that thus, this method provide poor stability. It is because of this there is no mean of stop of self increase in the collector current due to the temperature rises and individual variation. Okay. Now the second is stability factor is very high. Okay. Therefore, there is strong chance of thermal runaway. Okay, this is the disadvantages. Now, in the next coming class, we have seen about the stability factor, about what is stability. The next method, what is biasing with feedback resistance. Okay, thank you.